Hello and welcome, I'm your Code Monkey, and in this video we're going to create a damage circle that shrinks just like in Battle Royale games. Let's begin. So this is what we want to create. I have a player character here that I can move with a keyboard, and in here you can see that we have a damage circle, and the secondary is the target circle where the red circle will shrink towards. And if I go outside of the red circle, you can see that I start to take damage. If I go inside, the damage stops. So after a while, it shrinks to that, and it shows the next shrink position. This health system that I'm using is the one from Apex Legends, which was created in a previous video, so check that out if you haven't already. Alright, so let's get to it. So here is the starting scene. I have a player that I can move around, and in the UI in here you can see my current health. So let's start off by seeing how we're going to display our damage circle. So essentially we need to show a circle which is fully transparent inside and red on the outside. Now there are several ways we can do this. We could use a shader cutout and tint in red outside of it. That would allow us to make some special effects like some animation on the outside texture. Or we can just use a simple circle texture on a sprite render, which is what we're going to do. So over here in the textures folder, I have this texture in here. As you can see, it has a circle, red on the outside and transparent on the inside. For the pixels per unit, I'm going to choose the same as the texture size. So just like that, if I drag the texture, I have my circle shrink. And due to the pixels per unit, right now it's occupying 1 unit. So this is our circle sprite. Okay, so this looks mostly okay, but obviously we need to be tinted in red on the outside as well. So for that, we are going to create a new sprite render. And in here, in order to make it visible, I'm going to use just a simple white 1x1 pixel. This is just a simple pixel that is literally just a texture that is 1x1 in white. So by using that, the sprite is now visible, and now I can stretch it and I can tint it in red to match the outside. And now I need 4 of these for the 4 sides outside of the circle. And through code, we're going to set the size to correctly match the size of the circle. So that's pretty much it for how we're going to set up our visuals. Let's just rename this to more proper names. And let's put them all inside a container game object. Let's name this the damage circle and drag everything inside. And just like that. Okay. So now let's make a script to handle it. So let's make a new C# script. This will be our damage circle. And we're going to drag it onto our game object. Okay, so here on our code, let's first go into our await to grab all of our references. Okay, so we have our references to the circle and all of our sides. Now let's make a simple function to set our circle size. So we do a private void. Let's call this set circle size. And in here we're going to receive a vector 3 for the size. And inside, all we're going to do is go into the circle transform and set the local scale to be our size. So for testing, let's go here onto our awake and let's set the circle size to be, let's say, 200. Alright, so let's test. For testing, let's simply hide the others since we only want to see the circle size. Alright, let's run the code. And yep, the circle does seem to have a size of 200. Let's stop it, go into the circle, and there it is, 200, 200. Okay, great. Now we need to position and scale the sides. And for the size, it will depend on the total size of your map. It just needs to be stretched enough to where the player can walk so that it is always visible. Now we could do some really complex calculations to make the size perfectly fit whatever rectangle we want, but in here we're simply going for the similar way of just making it very large. So in here, for example, we would stretch it into there to where the player never goes past that. Same thing for the top and all the other sides. Okay, so let's do this through our code. So let's start off with the top. We're going to set the top transform.local scale. We're going to put this with a size of 1000, 1000. Now we need to position it. So top transform dot local position. Now, if you remember how scale works, it scales exactly from the middle. So in here, we need to move it up by half of our size plus half the size of the circle. So we do a new vector 3. This is the top transform. So for the X, we'll leave it on 0. And now for the y, we want half of our local scale plus half of our size. So the size.y times 0.5f. All right, so that should do it for the top. Let's test. And yep, there's the top. As you can see, it has a very large size of 1000, and it is correctly placed exactly on top of the circle. So in here, you can see that there's no seams. It's all very seamless. All right, great. Now let's do the same thing for the bottom. So we're going to set the bottom transform. For the local scale, let's do the exact same thing. Now for the local position, instead of going up, we're going down and then down on this. All right. Okay, there's the top in there, and down here, yep, there's the bottom. All right, so far so good. Now let's deal with the sides. First, let's set the left side. So we take the left transform and set the local scale. Now for the x, let's give it 1000. And now for the y, let's give it the same as our circle size. So the size.y. Then we move it to the left. So we do a left transform dot local position, and we set it. We move to the left by half of our size. So we take the left transform dot local scale dot x multiplied by 0.5f, and we shift this to the left side. And also by the size dot x, also half of it. And for the y, we'll leave it at 0. All right, so let's see if the left is working correctly. Yep, there it is. There's the left one, and as you can see, there are no seams. The left one is in there, the top is in there, the circle in here, and the bottom in here, and everything is pixel perfect. Now all we left is the right side. Let's see. So pretty much the exact same thing. So in here we do a plus. And yep, there it is. As you can see, all of our sides are correctly working, and now we do have a circle being visually shown. All right, great. So we can now dynamically size our circle, and everything else gets resized accordingly. So now that we have the size working, let's add another parameter for the position of the damaged circle. Now for the position, we could shift the circle transform and the top transform and all of these, and that would work. However, in here, as you can see, we are using a very nice container, so we can simply locate everything on the local position inside, and on the outside, we simply move this container. So let's receive a vector3. This will be our position, and we simply set the transform.position to be on this position. So in here, let's try putting it on the right side. Okay, so let's test. And yep, there it is. The circle is now on 100 in here, and it still has a size of 200, and all the edges work correctly. All right, great. So we have the circle where we want with whatever size we want. Now, obviously, we want the circle to cause damage to our player if he's outside of it. So let's make a function to test if a certain position is outside of the circle. So let's go down here, make a private bool, and let's call this is outside circle. And we're going to receive a vector3 for the position. Now in here to test, this is very simple since it's a circle. So we just need to calculate the distance between this point and the circle position. And if that distance is more than the circle radius, then the position is indeed outside of the circle. So let's go up here to store the circle size and position. And we're simply going to set it here in our function. So we now have these two variables that contain the current size and position of the circle. Now in here we return the vector3.distance. We calculate the distance between this position and the circle position. And we are outside the circle if the distance between that position and the circle position is bigger than the circle size. And in this case, the circle will always be uniform, so we can simply use the x. Now in here, however, this contains the diameter and not the radius, so let's multiply it by 0.5f. All right, so that's pretty much it. Now let's make a static function so we can easily call this from the player. And let's go up here to make a private static instance. So we can simply do a return on the instance that is outside circle. All right, so we have this function that we can call from anywhere to see if a certain position is outside of the circle. So here is my player class. Don't worry about the code in here since it isn't relevant for the damage circle. In here, all we need to do is test to see if the player position is outside of the circle. So for that, I'm going to create a function periodic. The function periodic is part of the CodeMonkey utilities that you can grab for free from unitycodemonkey.com. It simply triggers an action every certain amount of time. So we're going to execute the code in here every 200 milliseconds. And the code we want is simply to damage. And let's cause 10 damage every 200 milliseconds. However, we only want to do that if we're outside. So let's ask if the damage circle dot is outside static, and we pass in the player position. So if the player is outside, then cause damage. All right, so let's test. Okay, so here I am inside the circle with full HP. Now if I move outside, and yep, there you go, I'm now taking damage, and now I move inside and I stop taking damage. Go outside, take damage, inside, and you stop taking damage. All right, great. So we can set the circle size and position, and the player takes damage if he goes outside of it. So far so good. Now let's make our circle shrink. So here in the code, up here we're already storing the circle size and position. Now let's also store a private vector3 for the target circle size. This will be the size that we want to shrink to. Now let's make a update. And let's get the change vector between both sides. Alright, so using this we can now calculate the new size. And we're going to multiply it by a certain circle shrink speed. So let's define it up here. And then awake, let's set it to a certain amount. We're defining this as a normal variable, so we could easily change the speed. Now, after calculating the new circle size, all we need to do is just set it. So we set the circle size. Let's use the same circle position and the new circle size. All right, that should do it. Now let's set up our test here on the awake. We're positioning it on 0, 0 with 200, 200. So let's set the target circle size to be 100, 100. All right, so let's test and see if the circle does indeed shrink to half its size. Yep, there's a circle, and yes, it is indeed shrinking to half its size. And if I move away, take damage, move inside, stop taking damage. And if I stay at the edge, and yep, now I'm taking damage and move inside. All right, great. And it stopped shrinking once it reached its target size. All right, so with the size working, let's also add movement to our shrink. So we already have the circle position. Now let's make a private vector3 for the target circle position. And on update, we're going to do pretty much the same thing. We're going to define a vector3 for the circle move direction, which will be the target circle position minus the current circle position. Normalize the whole value. And we calculate the vector3 for the new circle position, which will be the current circle position plus the circle moved dir, multiplied by time.delta-time and by the circle shrink speed. And here we use the new circle position. All right, that should do it. Let's go up here and set the target circle position to be somewhere on the right side. All right, so let's see if the circle shrinks and moves to the right at the same time. And yep, there it is. The circle is indeed shrinking and moving to the right at the same time. All right, great. Now let's add a visual to the target circle. So let's duplicate our circle and use this texture in here. This one just has the outline of the circle. Now the way we set things up was that we were moving the container instead of the transforms inside, so we need to make sure this one is outside. And now in here, let's add a reference to our target circle. So a private transform for the target circle transform, and let's make this a serialized field. So we can set it in the editor. So here we are in the editor, select the damage circle and drag our target circle reference. Okay. Now let's go down here and create a function to set the target circle. So a private void set target circle, and we're going to receive a vector3 for the position and a vector3 for the size. And in here, all we're going to do is set the target circle transform, set the position to this position, and the local scale to this size. All right, so that position is the visual. Now let's also set the target circle size and target circle position. And now we can use this function when we go up here on our awake. We use this function to move it to the right side. So let's send 50 and 0. And for the size, let's again use 100, 100. All right, so let's test and see if everything is still working exactly the same as previously. Okay, so here we are. There's the target circle sprite showing where the circle will shrink to. And as you can see, the circle does indeed move towards it and is shrinking towards it. And now once it reaches the final size, it will stop shrinking. And yep, there it is, exactly like that. All right, great. All right, everything is working so far. Now let's make it shrink, but only after some time. So here on the set target circle, let's also receive a float for the shrink timer. This will be the amount of time that it waits before it starts to shrink. So let's store it up here. And we're going to set it down here. And now on our update, the first thing we're going to do is reduce our shrink timer by time.delta time. And then we're only going to actually modify the circle size if the shrink timer, if it is under 0. Okay, so let's test, and we're going to start shrinking only after 5 seconds. Okay, so here it is and everything is stopped. And now after 5 seconds, yep, there you go. It starts to move towards the target. All right, now let's make it shrink more and more each time. So on our update, let's figure out when the shrinking has been completed. So in here, since these are vectors, we can simply use a vector3.distance to calculate the difference between them. So if the distance between the new circle size and the target circle size, if that one is under a certain amount, and we also do a test on the new circle position, if both the size and the position are near their targets, then let's shrink again. So in here, let's do a set target circle. And we're going to, let's keep the same position, so the circle position. And for the size, let's shrink it a little bit. And we're going to shrink after 3 seconds. All right, so let's test. Okay, there's the first target size, and it's shrinking after 5 seconds. Yep, there you go. And shrinks once it gets there. Yep, it stops, and he set the new target size, and after 3 seconds, it starts to shrink. And again, it's gonna shrink again, and after 5 seconds, if I stay here in the edge, and yep, there you go, I'm now outside taking damage and move back inside. Great, so we have all of our shrinking logic working perfectly. Now all we need is to add some randomness. So in here, instead of always shrinking to the same position and by the same amount, let's make a new function. This will be our generate target circle. And in here, let's randomize how much we're going to shrink by. So let's do a float for the shrink size amount, and we're going to simply do a random.range. We're going to shrink by between 5 and 40. So the generated target circle size will be the current circle size minus a new vector3 with our shrink size amount. And let's also generate a new position. So we generate the new position based on the current position, then we randomize between minus shrink size amount and the plus shrink size amount. And finally, we need the random shrink time. And then we set all of this. So we do set target circle. We pass in our generated target position, generated target size, and the shrink time. All right, so now up here, instead of using this, we use generate our target circle. All right, everything looks good. Now let's test. Okay, so here I am, and that's the target circle. And after 5 seconds, it's going to start to shrink. Yep, there you go. Once it gets there, yep, it generates a new circle inside the current circle, and after a while, it's going to shrink to that one, and again, generate another one, and after a while, it will shrink again, generate, and so on and so forth. And in the meantime, everything still works, and if I move outside, yep, I'm taking damage, move inside, and now I'm safe. So there you have it. We created a damage circle shrink for a Battle Royale game. We can place a circle wherever we want with any size we can think of. There's an extremely simple function that we can use to test if a certain position is inside or outside of the circle. Our sprites are dynamically sized, so visually everything looks correct regardless of the total size. We could further expand it by adding more logic to change the shrinking speed, or take more damage the further from the circle the player is. We could also change it to make the moving and scaling always take the exact amount of time. All it would take would be some simple math. So this is a great base to add to your Battle Royale game. As always, you can download the project files and utilities from unitycodemonkey.com. If you have any questions, post them in the comments and I'll do my best to answer them. Subscribe for more videos and I'll see you next time.